All right, let's just jump right in. We are all getting way too familiar with deepfakes, right? The AI-generated video and audio are getting so good, so hyper-realistic, that telling what's real from what's fake is becoming a serious challenge. But what if the whole solution isn't about getting better at spotting the fake? What if it's about getting way smarter at verifying what's real? Today we're going to look at this really cool new approach called Echo Shadow.
And that right there is the million-dollar question, isn't it? As the AI gets more and more powerful, all the usual clues, the weird visual glitches, the robotic audio, they're all starting to vanish. So if a fake is literally perfect to our eyes and ears, how in the world are we supposed to catch it? Well, the folks behind this project think maybe, just maybe, we're asking the wrong question entirely.
And this is the big idea, the fundamental shift that makes Echo Shadow so different. It completely flips the script. Instead of training one AI to spot the little mistakes of another AI, it looks for violations of reality itself. It's a huge change in thinking, from hunting for fakeness to instead confirming the subtle, chaotic, messy rules of the real world.
So, how does it actually do that? Okay, the first layer of defense is basically a signal sanity engine. The best way to think about it is like a digital physics engine. It's not looking for weird pixels or strange artifacts, no. It's looking for those tiny moments where the audio or the video just breaks the basic laws of physics that govern our universe.
And what's so cool here is just how subtle these checks are. For example, when we speak, our vocal cords have this natural, tiny, chaotic waver that AI often smooths out, making a voice sound just a little too perfect. Or the system checks if the echo of a voice actually makes sense for the room you see on screen. Deepfakes even mess up compression. Sometimes they're too clean, liking the little bits of noise that real recordings always have.
And it's the exact same idea for video. Our eyes, for instance, they don't move in these perfectly smooth lines. They make these tiny, jittery micro-movements. Our head has inertia. It doesn't just snap from place to place. And get this, even the way light reflects off our skin is affected by the blood flowing just beneath it. These are tiny physical truths that AI models, which are just focused on the big picture, often get wrong.
Now here's the really crucial part. This whole first layer doesn't need some giant, power-guzzling machine learning model running on a server. It's just smart math. And what that means is it can run super efficiently right on your device, a phone, a body cam, whatever, without absolutely killing the battery. It's a fast, lightweight first line of defense.
Okay, let's move on to layer 2. This is what the creators call the killer differentiator. So if layer 1 was all about the physics of the world around us, layer 2 is all about the inconsistencies of just being human. It's designed to check for something they've named behavioral drift.
This concept of behavioral drift is just brilliant. Think about it. Real people are, well, we're a little messy, right? Our behavior changes when we're under pressure. We hesitate. Our tone of voice shifts. A deepfake, though, can be just unnaturally consistent, a little too perfect. So this layer isn't trying to figure out who you are. It's just trying to figure out if you're behaving like any real human would.
So what does that actually look like? Well, this slide gives us some perfect examples. Is the person's reaction time just a little too fast, too perfect, like a computer? Does their emotional tone stay completely flat, even when they're talking about something stressful? Or maybe their gaze is just unnervingly steady when a real person would be glancing around, thinking. These are the human glitches that AI really struggles to replicate in a believable way. So, how does this actually work under the hood? Well, basically the system takes all the audio and video signals and turns them into a sort of digital fingerprint of a person's behavior. Then, and this is the genius part, it doesn't try to match that fingerprint to a specific person. It just checks if that fingerprint falls within the normal, messy range of human behavior. Anything that's too perfect or just too weird gets flagged. This means it doesn't need to be trained on a bajillion deepfakes, it just needs a solid understanding of what's normal for people. Okay, so the system found a problem, a physical anomaly and a behavioral one. What happens now? Well, that brings us to layer 3, the cognitive field assistant. This part isn't about just spitting out a simple real or fake score. No, it's about empowering a human's judgment with actually useful information. This comparison really says it all, doesn't it? A score like fake, 82%, is not very helpful. What are you supposed to do with that information? But the Echo Shadow way gives you an explainable alert. It tells the operator why it's suspicious, hey, the eye micro movements are missing, and then suggests a concrete action, like asking the person to turn their head. This turns the system from a simple detector into a true co-pilot for the user.
All right, so the theory sounds amazing,
But does it actually work when things get real? To find out, the creators put this whole system through its paces in a series of mock attacks, simulating the kind of high-stakes situations where a deepfake could do some serious damage.
And they did not make it easy on the system. They tested stuff like AI voice calls, trying to trick an officer, face-swapped videos of a supposed official giving orders, and even synthetic proof-of-life videos in a hostage situation. And they ran all these fakes over real-world platforms like WhatsApp and Zoom, compressed, sometimes low quality, to make sure this thing was tough enough for the field.
Now, if you peek under the hood, you'll see it's built using a lot of standard off-the-shelf tools. But the secret sauce here isn't any one piece of software. It's the unique way they've combined everything: signal processing for the physics, vision analysis for the video, and anomaly detection for that behavioral drift. It's that blend of physics and psychology that really makes it work.
Look, for a system like this to actually be used in sensitive places, we're talking law enforcement, defense, security, and privacy, can't be an afterthought. They have to be baked in right from the start. And that is an absolutely core part of the Echo Shadow design philosophy. So, crucially, all of the analysis happens right there on the device itself. No data is being sent to the cloud for processing. It runs in a protected part of the chip, called a secure enclave, and if the device is ever tampered with, the system is designed to just wipe its own models. This is seriously robust, on-the-ground security. And the way this thing learns is just as smart. The device never stores the raw video or audio. It only keeps these abstract fingerprints of the anomalies it detects. Later on, those anonymous fingerprints can be securely synced to improve the entire system. But, and this is the big but, no personal or sensitive media ever has to leave the device. It's truly privacy by design.
This quote really is the perfect summary. Echo Shadow isn't just another deepfake detector in an endless cat-and-mouse game, trying to keep up with the latest AI. It's a reality consistency engine. By focusing on the timeless rules of physics and human behavior, it's aiming to be future-proof in a way that typical detectors just can't be.
And that leaves us with a really fascinating thought to chew on. As one kind of AI gets better and better at faking reality, maybe our best defense isn't to fight it on its own turf. Maybe it's to use a completely different kind of intelligence, one that's grounded not in imitation, but in the fundamental, unchangeable truths of our world.